And let's see, we got one more here to do. This is sort of the culminating kind of question where you kind of have to put everything together and understand what's going on. You're actually trying to show that this in fact is a parallelogram. And this particular one isn't very specific on how to do it. So all you have to do is use some kind of, coordinate geometry, right? But we're going to do like a coordinate proof here to justify why this is a parallelogram. And you've got lots of options. Remember, we've got all these options here. Do I want to figure out if both pairs of opposite sides are parallel? Do I want to figure out if both pairs of opposite sides are congruent? I can't, again, do the opposite angles, not for a problem like this, but that could have worked if I could have done the angles. Do I want to see if the diagonals bisect each other, like we did actually way back at the beginning? Or do I want to just show that one pair of opposite sides are congruent and parallel? All right, the key, though, to do these is you have to understand how this relates to the coordinates. If I want to show opposite sides are parallel, what calculations would I have to do? Well, if you followed what I did on the previous example, for parallel I had to use slope. If I want to show that opposite sides are congruent, right, I want to actually show that this length is the exact same as this length, or in other words, wink wink nudge nudge, if the distance between these 2 points is the same as the distance between these 2 points, guess what I would use? Distance formula. If I want to, I can't, okay, I'm like, what formula do I use here? I can't really use a formula here. I'm trying to think if I somehow could find right angles hiding in here, that'd be great, but I think that's a little too painstaking, and that would be sort of luck of the draw. Even though this one almost looks like it is, I don't think it actually is, and we'll see in a minute, but you could use slope to determine right angles by doing the perpendicular connection, but this is really not a viable option for this type of question. Do the diagonals bisect each other? Again, what did we do on the first example? We showed that we had a midpoint where the diagonals intersected. So I could draw the diagonals in here and see if they meet at the same midpoint. So that's midpoint. And then, of course, this one's a little bit of both of the other ones where you do one pair of opposite sides, you do slope and distance for one pair. That's what you would do there. So we have lots of options. I don't know, what are you more comfortable with? Do you like doing slope formula? Do you like doing distance formula? Do you like doing midpoint formula? Maybe you want to do, you don't want to do 2 of each, you just want to do 1 of each. I leave it up to you. My vibe for most people, honestly, for these kinds of problems, I think slope seems to be the most common choice of what people are comfortable with. So I'll do slope just for the purpose of this demonstration, but I'd be more than happy to demonstrate any of the other ones if you want. We kind of already did the midpoint. Actually, you know what? We already did do slope too. So I think for this one, you know what? Just for the sake of having a little variety, we did midpoint here. Where's the slope? I did a little bit of slope here. Let's actually do distance formula for this one, just to have a little bit of everything. So I'm going to actually find the distance from A to B, compare it to D to C. I'll find the distance from A to D and compare it to B to C and see if we really do get a match. And the distance formula, of course, just you do it enough times, you just remember it. I've never been a good memorizer. I only know this by heart because I've done it literally 8 billion gazillion times. I may have exaggerated there. All right, so AB. First of all, I need the coordinates. So -1, 2, 3, 1, 3, 1. Oop, -3, 1. B is -1, 0. That's B. C, I might as well get them all. 1, 2, 3, 4. 1, 2, 3, 4, 5. And D is 2, 1, 2, 3, 4, 5, 6. That's D. C. All right, so AB. I'm going to do -1 minus -3. -1 minus -3 squared. And 0 minus 1 squared. So this is -1 plus 3, which is 2 squared, which is 4. -1 squared is 1, so I get the square root of 5 is AB. Let's compare that to CD. CD is 5 minus 6 squared plus 4 minus 2 squared. 5 minus 6 is -1. -1 squared is 1. This is 4 minus 2 is 2. 2 squared is 4, which is the square root of 5. So guess what? CD equals AB, which means segment CD is congruent to segment AB. AB congruent to CD. We're halfway home. Now at this point, you could do the distance formula again for those two and see if they match, or you could do the slope for AB and CD, and according to our properties, that would be enough. So, you know what? I think I'm going to do that. This way you actually have both examples. You have a distance formula, and you have a slope on the same problem. So I'm going to do the slope now for AB, the line that contains this segment, and slope is y2 minus y1, 0 minus 1 over x2 minus x1. So this is going to be negative 1 over positive 2, so negative a half. The slope of CD is going to be 5 minus 6 over 4 minus 2, which is negative 1 over 2. That looks good. These are also parallel, right? So AB, I'll write it just a little bit under here. AB is parallel to CD because they have the same slope. Oops. Okay, oops. Cut off there a little bit. Because they have the same slope. So now we have our parallelogram because one pair of opposite sides are both congruent and parallel. We could have done the distance formula here and said that it's a parallelogram because opposite sides are congruent. We could have done slope formula here and said both pairs of opposite sides are parallel, if that worked. We could have found the diagonal, or drawn the diagonals and found the midpoint for both and see if they're the same, like we did in the beginning. And we have lots of options for a problem like that. Alright, so give this one a try, check the answer key, and be sure to let me know if you have any questions, and hopefully you'll be able to get through this kind of problem set from the review packet. Okay, good luck. See you guys later. Bye.